Thank you so much for coming. We've got a small group here, so feel free to interrupt me, yell. I think we have two-way communication, and so if you need to stop me, you need to call out something I've done wrong here, and a question I'm not answering, feel free. I do want this to be engaging. I want to make sure that I'm answering the questions for you. But roughly the goal for today is that basically I want to get everyone here building with Axelar. That is my number one goal, so you can be successful in applying for prizes and building a really cool interchain application that we believe is the future. So as we get started here, just a little bit of introduction. So my name is Stephen Fluin. I'm head of developer relations at Axelar. Before Axelar, I was over at Chainlink Labs for a couple of years where I built the DevRel team. Before that, I was at Google for about 5 years, running the developer relations team for Angular, as well as spinning up a couple more developer relations teams within Google. And then before that, I was in software consulting for about 15, or I was at Trello, and then I was at software consulting for about 15 years. So I eat, sleep, breathe software in kind of many different forms. And my real niche is trying to sit halfway between the business and the technology. Because what happens is if you don't have the technology understanding, the business decisions you're making make no sense because they're not based on the real trade-offs that are implicit in every technology that we build. And if you don't have the business, you don't know why you're building things. You don't know what the economics are behind them, the marketing, all those sorts of things. So I try and help developers all day. And then all night I build things myself and try and be the engineer. And that really kind of reflects perfectly into my mission, which has two parts. The first is to make you successful. And the second is to empathize and understand what it's like sitting in the chairs that you're sitting in right now, so that we can continue to make our products better, continue to make our stories better, the journeys, and really eliminate friction, eliminate headaches, and figure out how we can make you successful, given whatever definition you have for being successful. And I like to start talking a little bit about kind of why Axelar exists, because I think it can understand some of the technology decisions that we've made along the way. And so if you look back earlier into the years of blockchain, there were a lot of things that people kind of recognize, right? Like Bitcoin, you had Ethereum come out in that time. And these big players really dominated. One of the things I say is that 3 or 4 years ago, it was actually much easier for a new developer to get into blockchain, primarily due to this paradox of choice, right? There were fewer options 4 years ago. And so developers didn't have to go make a bunch of choices. They could just start building, right? You would just go learn Solidity and you'd start building smart contracts. But we live in a much more complicated world now where a bunch of new platforms have come out, and we're even seeing the rise of these app chains where more and more chains are existing just for a single purpose. And this actually makes your life as a developer much harder because you're like, okay, now I have to choose which technology stack I want to build and learn in. Do I want to learn Go and write Cosmos nodes? Do I want to learn Rust and write Solana? Do I want to learn Move? And so there's all these different choices, all these different chains, and the world has become very fragmented, where if you want to build an application that gets to users, you actually have to be in many different places. And so this multiple interchain world actually ends up being a problem for developers because it makes your lives harder. And our vision is that we don't want you to have to worry about that as much. And so we want you to actually be able to take advantage of this new world because it is richer and it is better in a lot of different ways. And so we ask questions like, what if you didn't actually care which chain you were on at any given moment, particularly when it comes to like users performing transactions, right? I know personally, whenever I do anything cross-chain and MetaMask or whatever wallet just keeps popping up, do you want to switch network? Do you want to switch network? Do you want to switch network? And it's just a big pain, and it's often slow, and it's fraught with like, okay, is this really the chain I want to be on? All those sorts of things. Second, what if you could take advantage of the differences between chains, right? Like there's a reason that there are so many chains existing, kind of to the previous slide, where some chains are focused on scalability, some are focused on privacy, some are focused on like transaction time, all of these things. Each of these chains has unique benefits and properties. And it would actually be a better world if developers didn't have to like make one of those trade-offs and say like, okay, I'm going to give up on X to get Y. What if you could actually take advantage of those differences? And the last one that I alluded to is there are users now spread across Web3. And so for you to be a successful application, you kind of need to be where your users are, both in terms of liquidity, in terms of interfaces, all those sorts of things. And so that is the world that Axelar is trying to help. So behind the scenes, Axelar itself is a number of things, but we have a proof of stake blockchain with Tendermint consensus, kind of built on in the Cosmos ecosystem. But we are connected to a whole bunch of different blockchains across a whole bunch of different tech stacks. And so this is a number that continues increasing over time. And when you look at Axelar, the way that I kind of think about Axelar, and I summarize it, is our focus and kind of the way that we see the world. We're focused on security and decentralization first. So how can we make sure that everything we're doing is permissionless, trust minimized, and really, really secure? Second, how can we make sure that we're as connected as possible? I think if you look on Axelar Scan right now, which is our blockchain explorer, you'll see that we're connected with like 37 chains right now. So this is a number that continues to increase, and we actually have some ideas for the long term about making new connections to both Web3 and Web2 kind of more self-serve, so you can have this kind of full continuity of experience. And the last one is really focused on developers. How can we make sure that we have the simplest APIs possible that let you focus less on how to be Interchain and worrying about the problems and the constraints that come with being Interchain, and more on your application? And so that's kind of the way that we approach the universe. When you look at Axelar from a developer API service standpoint, I tend to divide the world into two categories. Now, things are much more complex than this, but I'll try and keep it as simple as possible. So on one end of the universe, you've got the ability to send tokens. And on the other end of the ability, you've got the ability to send messages. And there's three different ways to send tokens, and I'll kind of go through each of these really quick. So the first, and one of the easiest for even users to understand, is what we call a deposit address. So what a deposit address does is it bakes the source chain that you're coming from, the destination chain you want to bridge tokens with, and the destination address where you want those tokens to go, and an asset. And it takes all those things, it boils it down, and it gives you a single deposit address on the source chain, whether that's EVM, whether that's Cosmos. And what happens then is any tokens of that asset type that you send to that deposit address automatically get forwarded to the destination chain and the destination address. So if you ever want to see this actually in action, you can go to a site called Satellite. So this is a front end we've built on top of this get deposit address capability, where basically you can select two chains. So we'll just do, I don't know, Avalanche to base, select the asset that you want to transfer. Sure, and we'll just say like 5, and then fill it with a destination address and hit generate deposit address. What this does is this asks the Axelar network, that blockchain, to create an address on the source chain, so on Avalanche, that anytime I send a USDC token to that address, it will automatically be forwarded to the destination address and the destination chain. And the nice thing here is that you don't actually need a wallet of any kind. So this actually enables you theoretically to interact with a centralized exchange or a decentralized exchange on your source chain, and then you can directly withdraw to a destination chain and a destination address, which is kind of magical. And so we have a JavaScript SDK that generates these deposit addresses. I'm seeing someone walking around. Can you hear okay? Still good?
Yeah.
Okay. All right. So that is a deposit address. And again, that is one of the easiest ways for any user to kind of move tokens around multiple blockchains with kind of automatic bridging via the Axelar network. The second one is looks very similar, and you're going to notice a very common theme of simplicity across all of these APIs that I'm going to talk through. But the second one is send token. So this is just a method that exists on all of the gateways. So we have a gateway on every EVM chain. And so it looks very similar. So you're going to pass it the destination chain name, the destination address, the asset you want to send, and the amount you want to send. So, and then with a normal token authorization of that gateway, you can bridge tokens very, very easily. And the last way that I'm going to show you to send tokens is actually something new that we built in the last few months. And we call these Interchain tokens. And what Interchain tokens are, it's really the ability to take any ERC20 on any of the EVM chains and level it up into a Interchain token, where that token exists on multiple chains, and it gives you the methods that you need to move that token back and forth between chains. So I'll actually do a really, really brief demo of this one. So the way that I'm going to do that is I'm going to pull up the Interchain token experience, and you're going to see once I've connected a wallet, it's asking me for what ERC20 I want to create. So let's go ahead and actually just create a token from scratch. So if I just jump to the Interchain token documentation here, we have a super stupid simple ERC20 that's kind of ready to go that you can go build and play with. So as you can see, it says my Interchain token. Maybe we'll call this like Lion Hack token, and we'll just call it like LHT. Make sense? So we're just basically minting a simple ERC20 using the OpenZeppelin interface. So we can go ahead and compile this, and let's actually go ahead and deploy this to a real blockchain. So I'm going to switch to injected provider, and then make sure that I'm on. I'll use Avalanche this time, and we will go ahead and deploy that token. So you can create an ERC20 however you want, but I just want to show you like take any ERC20 that exists in the world, including this one that I'm just building, completely vanilla, completely like pure Solidity code. And now we can go ahead and copy this token. I'll paste it into this interface. It will detect it, and it'll say, hey, we found this token, but it doesn't actually exist on any other chain. Do you want to turn that into an interchain token with versions that exist on multiple blockchains? And so I'll just hit register token. It'll detect that token. And now I have the fun choice. What chains do I want to deploy to? So I will deploy to, how about Polygon, Moonbase, and that's good. Obviously, I could pick as many of these as I want. All you have to do is you have to pay the gas on the source chain to pay for all the transactions on the destination chain. So if I pick everyone here, I just pay more gas on the source chain. So pretty straightforward. I'm going to go ahead and hit register. What's going to happen is it's going to ask MetaMask to do that on-chain registration on the source chain. And then it will use Axelar's message passing to send a message to all the other chains to register that token there and actually create those ERC20s all over the place. And so I'm not going to wait for these tokens to be created, but we'll come back to this a little bit later, and we'll actually see if it created that interchain token that allows us to move tokens kind of back and forth. All right, so with that, we've now kind of seen the three ways of moving around tokens. To me, sending tokens is a critical, fundamental, important primitive for building anything that is cross-chain. But it's also limiting, right? Tokens are great for DeFi, they're great for portability of liquidity, those sorts of things. But I like to see people leverage their imagination. And so we actually focus more on the second half of sending messages, because when you can not just move tokens between blockchains, but you can also send messages and actually interact between contracts on two blockchains, that's kind of where the magic happens. Because you can think of it, instead of moving assets to compute, you can move the compute to where the assets are, which is just kind of a very, very cool idea. You're going to recognize these APIs. So we have a call contract method that exists on the gateway of every EVM chain, and it's coming to Cosmos as well soon. Basically, you give it the destination address, the destination chain, and a payload. And then we have a perfectly matching method that you need to implement called execute that then gives you the source chain where the message came from, the source address that it came from, and that payload. And you'll notice that this is an internal method because what's actually happening is the Axelar network, it's doing a decentralized consensus behind the scenes. And let's actually take a look at what that looks like in a second. So before I do that, I do want to mention one last thing, which is that all transactions on blockchains cost money or currency of some form. And so doing this within an interchain world can actually be very complex. And so what we've tried to do is we've tried to boil it down into a single method. And so what we allow you to do is we pay the native gas on the source chain for the contract call end to end. And so effectively, you give it all the data about the message you're trying to send, and then it's able to pay for the execution on the source chain, the Axelar decentralized consensus, where you actually have independent validators voting, and then the execution, the approval on the destination chain, where you're verifying that consensus and then actually calling your contract, that could be very simple or could be very complex. So all of that you can pay in the source chain, so you don't have to go and make payments on a bunch of different chains and maintain currency everywhere. So if we follow the flow of general message passing, you've got your source chain with some sort of app logic. You're going to calculate a fee and pay it to that gas service. Then you're going to call the Axelar gateway and say, hey, I'm calling this contract, this destination contract on this destination chain. That will then be confirmed by the Axelar network, where every validator has an independent vote and say, hey, did this actually happen on the source chain? And so once they have that decentralized consensus, they all sign that message and say, hey, yep, this should happen. This should execute on the destination chain. And then the destination gateway actually verifies those signatures and executes your contract execute method. And so this kind of nice flow is all initiated by those three very simple methods. So I thought, let's actually go ahead and do a demo here. So what I'm going to do is I'm going to build a simple message passing contract that you could then extend kind of however you want. And so I've asked a lot of developers, and folks have said that they like to see it kind of from scratch. And so what I'll be doing is I will be building it from this completely blank remix file. What are we going to do? So we're going to need a couple of things first. So let's go ahead and just set up the basics. So I'm going to say Pragma, Solidity, and we'll take any of the 0.80 versions just to get the latest Solidity compiler. And then we're going to create a contract, and we'll call it sender receiver. You could call this contract whatever you want. But now we have a basic Solidity contract. So obviously this doesn't do anything yet. So if we wanted to do something, we're going to need a few different imports. And so I'm going to make 3 imports. I'm going to import the executable, which we're going to extend for this contract. And then I'm going to import the gas service and the gateway so that we can interact with them. So let's go ahead and triple cursor it up here and do import from Axelar network, Axelar GMP, SDK, Solidity. In every demo, I make a fat finger here, so keep your eyes open. And then we'll just end this with .sol, and then we'll import our specific symbol. So first thing we're going to import is Axelar executable. That's what we're going to extend. And that is from executable / Axelar executable. And then we're going to import our iAxelar gateway. So it's just the interface for the gateway. And that's going to come from interfaces / iAxelar gateway. And then lastly, we're going to import the interface for the Axelar gas service. I'm going to get that from the interfaces folder as well. All right, in order to take advantage of these things, we're going to do a few things. So first things first, let's go ahead and actually give ourselves a place to store that gas service. So we'll just say this is a public immutable gas service. And now let's go ahead and use our constructor to ask for these things when you create this smart contract, because the address of the gas service and the gateway might be different on every blockchain. And so we're just going to take those in as parameters for the constructor. So let's go ahead and say address of the gateway and the address of the gas service. Now, in order to save these out, I can actually just extend the Axelar gateway for the gateway, or extend the Axelar executable for the gateway. So we'll just pass it to that constructor, our gateway, and then we're going to save locally that gas service that we talked about. So I'll just say gas service is going to be equal to an iAxelar gas service of the gas service address. All right, we have a typo here. I don't know here. All right, I'll figure it out in a second as we go here. So once we have these, that's so weird. I've probably just fat fingered address or something like that somewhere, but we'll figure it out in a second when we start debugging. So the main thing that we need to do is we now need to create two methods. So we've got a sender receiver. So we're going to actually build both sides of this contract into the same contract so that we can just deploy it everywhere, and then every blockchain can communicate with every other blockchain. And so we'll first create a function send message. And this is going to take 3 parameters. They're all going to be strings, and they'll all be call data. And the first one is destination chain. The second one is going to be string call data destination address. And the last one is going to be string call data, and we'll just take in a message. So this could be any message that you want to send to a destination chain. And this is going to be external, so that anyone can call this. And it's also going to be payable, so that we can pass in some extra token, extra currency to pay for the gas service. And so the first thing we need to do in order to calculate the gas service is we're going to actually need to figure out what our payload is. So what we'll do is we'll just take our payload and we'll set it to type. Payload is going to be equal to an ABI encoding of the message that we just received. Now that we have that payload, we're going to ask the gas service, or we're going to actually take the value that was passed to our contract and pay that out to the gas service. So we'll call the gas service dot pay native gas or contract call. Pass it the entire, hit the entire value. And then the parameters we're going to pass it are going to be the address of the contract, where the call is going to be executed from, the destination chain, address, payload itself, and who actually initiated it. All of this is just used to match the contract call so that we know what's being paid for. All right. So now we've paid for the full end-to-end contract use, or the independent validation on all the source, Axelar, and destination blockchains. So let's go ahead and just call our gateway. So we're going to say gateway.callContract. We'll pass the destination chain, and we'll pass the destination address and the payload. So with those 3 things, the gateway now knows is able to emit the right events that the Axelar network will pick up, see that this message has been created, confirm it by decentralized consensus by the validators, and then execute it on the destination chain. And so for us to actually execute on the destination chain, we need to implement an execute method. So these are going to take something very, very similar. So we're going to say string call data source chain, string call data source address, and bytes call data of our payload. So this is whatever payload you want. So I'm doing a string here. This could be anything. This could be an array. You could have different. I've implemented smart contracts where you actually can do a switching. So you could like have the first parameter in the bytes be like, which method do you want me to execute, and then switch based on like what sort of, is it an initial registration? Is it an update? Is it an overwrite? All those sorts of things. So this is going to be internal override. And we're just going to say the message. And we actually need a message variable here. So let's go ahead and create that. So we'll just say string public message. And we're just going to say message is going to be an ABID code of our payload as a string. All right, so that really should be it. And let's figure out where all the errors are. Okay, the error with the constructor is gone. I think the compiler was maybe just slow. Let's triple check. Undeclared identifier. It's a little bit smaller so I can see the lines. Gateway should match up. Ah, this is why. It couldn't extend Axelar executable because it wasn't actually an Axelar executable. There we go. So let's just say it isn't Axelar executable. So that has now given us this constructor ability, and it's now given us the gateway parameter. The only remaining warnings here are the fact that we're not actually using these two parameters, but we don't care about that. That's just fine for this demo. Right, so let's go ahead and now compile this, and let's start deploying it. So in order to deploy this, I need to do a couple things. I need to give it an address for the gateway and an address for the gas service. So those are actually very easy to find if you just jump into the Axelar documentation, resources. So we're going to do this on testnet, and I can just copy and paste whatever addresses I want. And so, for example, if I wanted to initiate this contract call on Polygon, then I would just look up the Polygon. So we'll copy the gateway contract here. We'll copy the gas service contract, and we will hit transact. Which, my RPC provider for Polygon Mumbai has failed, so that's not fun. I in the last Q&A I did in my last talk, they asked the biggest problem with building in blockchain, and I said RPC providers. I don't know if anyone else has issues with RPC providers often. So let's just switch blockchains because it doesn't actually matter where we're sending and receiving from. So let's go ahead. Let's start on Avalanche, and we'll see if Polygon comes back or if we need to do something different. All right, Remix. Can you do it? All right, I don't know what Remix is doing. Let's refresh it. Let's start over. Not from scratch, hopefully. Yep, we've got our code sample here. And then let's see, compile it. And can we deploy it to, yeah, there we go. Okay, we're connected to Avalanche now. So let's, instead of Polygon, we'll do Avalanche. Here we go. I'll paste in the gateway contract and the gas service. We'll see a MetaMask transaction actually create this contract. And then in just a moment, we actually should get back the address of our contract. Perfect. So now on Avalanche, we have a contract that is capable of sending and receiving messages. Now we just need to deploy this somewhere else in order to actually see it. So let's see what blockchains we actually have tokens on. How about, let's go old school and do, actually, let's go new school. I'll do girly. Sorry, 7 girly. I'm rich. Do you know how hard it was to get 7 girly? It took forever. All right, so let's go ahead and try and deploy this to girly. So what I'm going to do is I'm going to do the same thing here. I'm just going to copy, paste the gateway, pass it into the constructor, as well as the gas service. Go ahead and pay the gas in order to create that contract. And it is pending on the blockchain. Girly's one of the reasons I don't use Girly for demos usually is because it's a little bit slow. So we'll see how long this takes. Perfect. All right. So now we have our 2 smart contracts that have been deployed. And now what I'm going to do is I'm going to switch back to Avalanche because the gas is cheaper. and I'm going to go ahead and interact with my first contract, and I'll initiate a message from Avalanche to Gurley. And so now I'm going to actually interact with my contract here. So I'll just use this little interface on the side, and I will say send message. And so the destination chain is going to be Avalanche. Actually, no, it's not Avalanche. Destination, we're sending from Avalanche to Gurley. So I need to copy this one. And the Gurley string name is Ethereum 2. So we'll just copy the chain name, make sure we get that right. And the message. What message do we want to send? Someone yell something out.
Hello, world.
Hello, world. I love it. Okay, so the last thing I do is because I need to pay for that gas for the full end-to-end interchain transaction, I'm going to just go ahead and throw 1 AVAX in here. So we'll pay 1 AVAX, and we will transact that. And if I built the contract correctly from scratch, this will all work, which we definitely may have made a mistake along the way, but we will see here. So we're submitting this transaction. So we're just calling that send message method on Avalanche. And we should actually now be able to see that transaction ID. There it is. So in order to actually understand what's going on, obviously I could go to Snowtrace for Avalanche and look and see, okay, what's my transaction, what's happening? But that doesn't really give you the full end-to-end picture of what's happening interchain. And so I want to introduce you to this really helpful website called Axelar Scan. So I'm on testnet.axelarscan.io. You could also just go to axelarscan.io. What I'm going to do is I'm going to paste in that transaction ID. And so Axelar Scan is something I absolutely love because what it does is it takes these really, really complicated multi-chain transactions and it gives you a single interface, a single concept of a message, right? You can see, here's my call contract, here's my source chain, here's the contracts involved, here's my destination chain, and then you can watch it as it flows. So everything from the contract call, the gas payment, confirmation by this is the decentralized consensus on the Axelar network, all the way out to that call being approved and executed on the destination chain. And so you can see all those transactions, all the gas that's being paid, kind of everything along the way. And so sometimes these transactions can take a little bit of time. It entirely depends on what chains you're using, because one of the things that we have to wait for is finality on the source chain. And so because until a source chain has said that this transaction is final, it wouldn't be safe to transmit it on another blockchain. And so finality time varies based on blockchain. Ethereum is like 15 minutes. So just a heads up if you're trying to send any messages from Ethereum. I found that Avalanche, Polygon are a little bit faster, but we're always waiting for that finality concept because if things change, if the definition of truth changes, we don't want that message delivered. You don't want that message delivered. And so I'm not going to sit here and wait. What we'll do is we'll come back when I finish the rest of the talk, and we'll check and make sure that worked. All right. So we've sent a message. The Axelar network detected it. So we've actually built our first successful contract that uses this call contract. There's also an equivalent that you can call contract with token if you need to be doing message passing at the same time as sending tokens. So obviously you can you've seen how to do it from scratch. You can remember everything I typed and go do it yourself, but we will actually want to make this a little bit simpler. And so we have this fantastic repo, which is for any hackathon where I recommend everyone starts, is cloning github.com/axelar/axelar-examples. And so what you'll see in the Axelar examples repo here is, let's just code. I'll just make this very big so everyone can see. So what this is intended to be is a starting point and an example code that really accelerates anything you want to do. And so if you're looking to use this repo, just check the series of readmes. These are very simple. So it has things like clone the repo, run npm install. So let's just run that in the background to make sure it's working here. Npm run build to compile the contracts. So none of this should be very surprising. And then what we're going to do is we're going to run this npm. Actually, I've already created an environments file, which I'm not going to recreate at this moment. And then the magic command here is npm run start. What this is doing is this is using something that we call Axelar local dev, and it's spinning up 5 local blockchains. So this is 5 copies of Ganache effectively. So you've got Moonbeam, you've got Avalanche, Phantom, Ethereum. So these are all basically equivalents of the blockchain that you'll see on testnets. And we're deploying all of these tools like the Axelar gateway, the gas receiver, a version of tokens, so that you can do all this very easily locally. And so now that we have this network up and running, I can actually jump into one of our examples and execute it against our local blockchain. And so the first example that I point everyone to, and the one that I use the most, is actually in the example/EVM folder, and is called call contract. So this is that exact same kind of sender-receiver type contract that we just built, just written for you. And then what you'll see also is it's not just written for you, but it actually has an index.js that is capable of deploying to all those blockchains for you locally and executing. And so let's actually run the execute method to show off what this looks like locally. And so if you ever want to know how to use one of these examples, just check the local README. And so we'll just say npm run deploy, and we'll give it the example, and we'll do it on a local environment. So you can actually use all these examples on testnets as well if you want to just take the code and deploy it there. So as you can see, we deployed the call contract to all these blockchains. There are the addresses, and now we can go ahead and run this command again. Instead of deploy, we're going to execute. So it's on Phantom, there's no message. And then we're initiating a message from Avalanche. And so finally, the value at Phantom is hello Phantom from Avalanche. And so we have just sent a message from one blockchain to another. And because it's all local, it's fast, it's instantaneous. It's much easier to do an iterative development cycle where you're improving the contract, changing the execute method, all of those sorts of things. So Axelar examples is really, really fantastic. We've got lots of different examples here. So I talked about call contract, I demoed that. We've got with token, we've got cross-chain lending examples, NFT linkers. And then another thing that we have within here, if you go outside again, you're going to find this examples web folder. And the examples web folder basically takes everything we just did with our server and our command line executables, actually gives you a React Next.js front end that already interacts with these things. So if you are trying to build a front end for your application as well, maybe use the examples web instead to kind of kickstart that as well. So the instructions are almost identical. And I think I've already done all these. So I'm going to skip most of these. So what we'll do is we will rerun the server, clear out all that previous state, and we'll go ahead and run npm run deploy in our examples web folder. It's going to deploy all the contracts. It's going to build and deploy all the contracts we need for our web examples. And then we'll just run our Next.js local environment with npm run dev. All right, server has been started on port 3000. So let's go ahead and take a look. All right, so here you can see a bunch of examples with a UI. So again, these are the same principles that we've been taking a look at. So you've got a cross-chain messenger. So hello world again. Hello world. Make it a little bit more fun. Let's send, and we refresh over here. You're going to see that message go across. And all of these are really using the blockchains that we just deployed. And so you can know that they're going to work on testnet. They're going to work on mainnet when you go. And then some of these examples, they look stupid simple, but obviously the code behind is what's really valuable. So this is a fun one as well, which is we've got an NFT that exists on Ethereum. Let's go ahead and send it over to Avalanche. There's the transaction locally, and there it is. And then you can send it back. So I mean, it doesn't seem as exciting, but if you look behind the scenes, you now actually have all of the contracts that you need to be sending NFTs, linking them, all those sorts of things. So again, anything you're building for the hackathon, I highly recommend take Axelar examples and use that as your starting point, and then build on top of that, customize it, tweak it, all those sorts of things. All right. We also have a bunch of I've gone through a couple of these things. We're building a library of tutorials. So just check out the Axelar core YouTube channel. We've got send token, we've got interchain tokens, we have call contract. So all of those, we have these examples, and we're building more and more all the time. But I know that doesn't help you a ton this weekend, but definitely check out the ones we already have. So before we wrap up, I actually want to go and see. So let's go ahead and take a look at our interchain token. So let's hit refresh here. So the Avalanche token that we created with a balance of 1,000 now exists on both Polygon and Moonbase. So if you go ahead and look on the explorers, you can see there's no balance there. If you send token from Avalanche to Polygon, there will suddenly be a balance here and remove that from the balance here. So you now have a token with the methods that you need to be sending your custom token kind of anywhere across Web3. And then the last demo we did was the call contract. So let's see if that is finished. Perfect. So our Avalanche message ended up on Gurley. And then to actually prove that this worked, let's go ahead and jump back to Ethereum. All right, jump back to Remix, jump back to Gurley here. And let's check what the message is on our second contract. So here's our second contract. Hello world. So our cross-chain transaction is complete. The message was delivered, and we have now built our very minimal interchain dApp, and we've been completely successful. Hooray! Thank you. Thank you. All right, so you are in the midst of a hackathon. So what's next? So if you need support during this hackathon, both on the Lionhack server, we've got Axelar help, as well as you can join the developers channel on the Axelar Discord. I'll basically be making sure that we're checking in every few hours during the day. So you might be 4 or 5 hours before you get an answer, but we will make sure that we're answering all the questions today, tonight, and then tomorrow morning as you're finishing up the hackathon here. And we're really excited to see what everyone builds. So that is going to be it for me. Thank you so much for the time and the attention. We have a survey here if you have thoughts or if there's ways that we can make this more useful for you in the future.
Steven, do you have some time to answer some audience questions?
Yeah, absolutely.
Anything that has. Yes.
Stephen, I'm here with Bergen and Andy, and I'm sorry that makes it a little weird, but we're really curious about how you approve messages on multiple chains.
Sure. So I will try and break this down. So the easiest way that I visualize it is I'll pull up Etherscan again, or Axelar scan, excuse me. So the steps that it goes through. So this contract call is your invocation of call contract on the source chain. Then you have the paid native gas for contract call. That's the gas paid. Confirmed is the Axelar blockchain block that was actually created. That is the decentralized validators saying, hey, please vote on this. And so then once they vote on it, then they all sign that message. All the validators said this was true. They sign that message. And so approval here, if you actually look at it, is a method that exists on the destination blockchain where those signatures are passed in and validated. And so each of the gateways has knowledge of the validators on the Axelar blockchain signatures, so that that's what authorization actually does. Is it says, hey, it's a fixed size transaction where it says, here's the signatures, was the transaction valid? And if the signatures match the signatures of the validators and their stake, then the transaction is approved and can be executed. And so then execute is actually just an execute method that exists on my contract, which we might, yeah, you can see it here. So execute is this method that's actually being coming from our Axelar executable that basically only a signed valid transaction that has been approved on the gateway can execute. And then once it's validated, it actually passes it into my _execute method, that internal method that we wrote. Is that answering the question about how do you approve on multiple blockchains? So if I write a contract here and I send 10 messages to 10 different blockchains, there's going to be 10 different approvals across all those different blockchains. I will also say these approvals are batched. And so like if the Axelar network has 50 transactions to Polygon, it can approve 50 transactions in a single message in a single block.
You guys can just maybe ask instead of using the mic. Hi, Steven, can you hear me?
Yes, I can.
In your function above, little confused with what source chain edges aren't used at all. Yeah, right there. But if I want to use those like a smart how would I start going about doing any suggestions?
I heard in the method with source chain, and then the audio is like breaking up a little bit. If you can repeat that a little slower. I mean, it's not the microphone. It's the, I don't know, your connection's breaking up or it's cycling in and out.
In this, can you explain what source chain and source edges are used if I want to use a smart contract?
Sure. Okay, so what I heard is can I explain why source chain and source address aren't used in this example and how I could use them? Okay. So I don't use source chain and source address in this contract because I don't care where the message came from. Like I'm treating all messages that have been validated by Axelar Gateway as valid. Whereas you may want to say, hey, I only trust messages from this address. So imagine if I had set up my contract and I said, like, I don't know, hub, like, so maybe it's like sender receiver hub, public immutable hub, and then I set that hub as part of the construction of all of the other contracts that I deploy to all the other blockchains, and then I verify that messages can only come from the hub. Because otherwise, if you don't verify your source chain source address, and maybe that's okay to you, like depends, right? Like it depends on the use case that you're building, but someone else could come along and build a smart contract that then can interact with yours. Like I could send a message to your smart contract on Avalanche from Moonbeam.
Thank you.
And you can actually, like, I was very suspicious of these at first until I poured through the code. The reason you can trust these is because this comes from the signed consensus from Axelar. And so in the same way that we know that the transaction happened on the source chain, we know where it came from. Great questions.
Thank you. I got the questions. Like, yeah.
Awesome. Well, thank you everyone so much. Have a great hackathon.